All right. Hi, everybody. I'm Lizzie. I am one of the Student Learning Hub coordinators at C2 Smart. Welcome to our first webinar of the fall semester. The Student Learning Hub is an education and workforce development initiative that offers applied learning and skill building opportunities to help you develop research and job ready knowledge. Today's course is Introduction to Online Recommendation Systems from Predict Sort Architecture to Real-Time Feature Service. This session, which will also be uploaded to YouTube, introduces how modern online recommendation systems like TikTok Shop deliver personalized content in real time. We'll walk through the overall system architecture and then focus on the predict source stage, explaining how ByteDance, feature service, and user data accessor enable large-scale feature computation using an operator framework and a domain-specific language. You will gain insight into how these components work together to achieve millisecond-level predictions. Today's instructor is NYU's Hangdao Meng. He is a passionate and detail-oriented computer science enthusiast with a strong foundation in software engineering, machine learning, and data science. And he is currently pursuing his master's degree in computer science at NYU and previously earned his bachelor's degree in information security from Beijing University of Technology. And with that, I'll hand it over to him.
Yeah, hi everyone. Let's just start our topic. Yeah, and today I will work on the online recommendation system and just as the Daisy said, from the predict store architecture to the real-time feature service. And yeah, and in and this recommendation system will include the some of the components, including the UDA, the user data accessor, which is a user data processing part, and of course the feature service, and also the predict and sort stage, the heart of the recommendation system, and how we store the feature about a feature repo. Yeah, just a short introduce about myself. I'm right now pursuing my master degree in computer science in Tandon, and I'm an ex and community cloud software engineer intern and focusing on the recommendation system. And here is my personal website. If you are interested, you can follow my website. Yeah, and here is the short overview of the whole course. And in this 40 or 15 minutes course, and we will focus on the online recommendation system, and we will focus on to explore how the recommendation system to impact the online shopping and the social media, just like daily life, like TikTok, like Instagram, like Amazon, and then we will understand the high level architecture of the whole recommendation system, like the user item interaction and the customization and the sorting or the ranking. And I will talk it in the academic way. And finally, we'll learn how to implement or to deployment a recommendation system in an engineering way, like how to build a real-time pipeline and how to build a really back end the diag the directed acyclic graph structure to support a distributed system, and how we control the whole distributed system with the Python-based domain-specific language control. Yeah, and yeah, so why we use the recommendation system or how the recommendation system work in our daily life, and you can just see the recommendation system is everywhere in our daily life. When you're shopping online, uh, when you like watch some short videos like TikTok, like Instagram, and recommendation system work everywhere. Like especially in sometimes you want to pay something, want to buy something. Yeah, and here is the recommendation system, and they will always recommend something like you really interest or you really want to you and for you to buy it or watch it. Yeah, and why we use the recommendation system for this kind of situation, and there are three reasons. And the customer the customer lives, and they reduce the overload, and they have a business impact. Like uh just think about like the Amazon, the Netflix, the TikTok, the Instagram for you in your daily life, and you scroll the screen to search to find, and the system has like millisecond to guess what is the next best for you, what is the next item, or what is the next like video or other kind of things or person for you to find to search. Yeah, and everything happened in milliseconds. Yeah, and just show of hands, like we discovered a product from a recommendation system this month, right? So if you search some topic like you're a photographer, you like camera, you always search some the camera like Fuji, like Sony, and or you search some like the triple the lens in the Amazon or Best Buy or other anyway other things, and when you refresh your page and the next things, maybe four or six are the camera just you search. That's how the uh, recommendation system work in your daily life. Yeah, and yeah, okay. Um, Next, we'll talk about like how it works in a high level view. And basically, the recommendation system is super familiar with other searching engine or even in a if you know right now we have a RAG system, the retrieval augmented generation, and they are super same things because all of them are searching engine, just like the Google. Yeah. So basically all of the searching engine have this baseline component. The first is recall layer, and the second is predict, and the third is sort, and or other things have a re-rank or resort, and finally we have a server layer to for the like the user interaction UI. Yeah, and just as this the graphs and if you are a user and use like Amazon to buy something, and here is the request handler. Yeah, when something happen or something to trigger the action, like you click or search something like two times or four times, and then the request handler will catch your action, and then they will send your action to the predict stage. And here is the things, the predict stage, we will talk it later, and we have a backend technology to support the whole predict stage to support the whole recommendation system. Yeah, and the predict stage, which means we use our model. We have a model interface to accept the request handler's output, and then we predict to give it a score for each candidate. Yeah, firstly, we will use a recall to feature thousands of candidates, like 2,000 or 3,000 items. You might be like you might be like it or to buy it. Yeah, and after the predict stage, and we should have a sort because the recall find like 2,000 candidates. Not all of them you need, so we need to sort it and rank it, like find the top 10 of it for the recommendation. Yeah, and so which is super easy. So the sort layer, which means to rank the items and based on the predict score or the relevant score, or add some business rules, business logic in here to do the re-rank. Yeah, and nowadays some of the company use the LLM to do the re-rank in the semantic layer. Yeah, and finally is the server layer, and which deliver the ranked feed to the user interface. So the user, you can just in your application or website, you can find the new page and like maybe four of six the camera in here. Yeah, right. And all right, here, yeah, let's turn into the predict can just say the specifically of the predict store stage, and which is the heart of the online pipeline. Yeah, because all of the things, all of the core things of the recommendation system is in the predict and store stage. And yeah, just as a we got a candidate from the recall layer, and oh, here is the one component, important component in the recommendation system, the user data accessor, which just as the name said, is a user data processor. Yeah, and we got a different users data from the different data source, and to get it like the items info and the context info and the user info. Yeah, and we put all of the feature this kind of info to the model to predict. Yeah, and yeah, when just as you are a user to buy something in the online shop and you swap and to trigger this predict and sort request, and the UDA, the user data accessor, will put the user side row signal for like 2000 or maybe more candidates, and they will give it to the feature service, which is the second, or which means I think it's the most important service of the whole recommendation system, which is the feature service to transform the raw data into the model ready feature. In the online recommendation system, this kind of like we call it extracted feature, which means we extracted the raw feature to the extracted feature, and which is the model ready feature. We can directly put it as an input to the model, and model can use this kind of input to predict and to calculate the score and to output the final result of the recommendation system. Yeah, and after the user data accessor and feature service, and yeah, these two kind of things make the predict stage easy, and we just uh to run the model and use the output of the feature service as the input, and we can output the score. And the sort is super easy after feature service. So sort is just to rank the candidates and apply the re-ranking or filter logic. Yeah, and just as a easily example we mentioned before, like if a user like swap or click the camera item recently, and the UDA will return the recent uh many kind of the feature based on the user. Oh, here the feature is a super important thing. The feature means like um uh for the person, and feature means like it's a key value. The key is like the click time, and value is 20. That's a super easy feature. And the feature is the source to feed the model in a two-way. The first is the feature is to feed the recommendation model for training in the offline recommendation system, which means we can get a stronger system or model. And in the online recommendation system, the feature is the input to search the relevant score. Yeah, so the feature uses in these two ways. So yeah, and when a user to click something, and here is the action, and the UDA to return the recently feature like the click times, stay times, or yeah, some other user state or user behavior, and oh, and to put the things to the feature service, because the UDA feature raw data, the raw feature, which means the key value, the click times and 20s, and feature service will compute the key click time 20s to the uh, model ready, which means it's a vector, and to compute its real-time feature to feed it to the predict model. And the compute times is another important things we will talk later, and which means we make sure everything happen in a millisecond. Yeah, and the sort means we rank the score and to output the top 10, top 12, like top 20s video or item for the user to display. And yeah, and let me talk more specifically about a user data accessor. And just as we mentioned before, is a user data processor, and we can use it to fetch the user's data, like the user's feature, yeah, the raw feature of the user or item or context. Yeah, when we use it, uh, because everything, especially the online recommendation system, happen in the millisecond times. So we should make sure that everything happen really fast. Like you don't wanna like you online shopping wait too many times to give you a recommend. And actually in the real life product and when you swipe or click or something action and the things make really fast can because maybe the next swipe and everything changed then and you finally what you really want in this page in the new page. So, so the UDA provide a fast and consistent data size for the online serving, and it will the purpose of using it because it's fast, consistent, and user-side data for the online serving, and it will return the normalized user feature like just like the big times, yeah, and it will return it really fast, of course, and which guarantees the latency like less than 2 milliseconds per request like that. So here is the uh, like a data structure of it, or the per day give you a request based on the user action, like click so many times, and the UDA will use a get or method like just a fake methods function and you based on the user item or user or item ID, and we can find the watch time, click time, or some others features of the user or item. And yeah, let's move on to another super important part, the feature surveys, which is I think is the feature survey is the whole recommendation system. Yeah, it takes most of the time of engineer to develop it. Yeah, in the predict stage, yeah, in the feature service is used to extract the raw data and raw features for the user item and context into the model ready, the extracted feature, which is a vector. Just as the graph, the candidate, yeah, of course, we use a recall methods to get a thousand of the candidate, and we use the UDA to retrieve the info of all of them, and we pull the after retrieval data, which is the raw feature, into the feature service. And feature service extract the raw data to the extracted feature, which is in the math is a vector, but for the whole system is a model ready feature. We can directly use it to as an input for the predict model and to output the score. Yeah, and and it's also a real-time feature extraction and the transformation powered by the feature service, and which guarantee two things. First is our online recommended for the online recommendation system, and we use the feature service to deal with the data from the raw feature from the UDA, and we output the model ready feature, the extracted feature for predict stage to predict the score. And we and that's for the online recommendation system. And for the offline recommendation system, the offline firstly the online recommendation system is for the user to improve the user behavior when they're shopping or they are uh, like swap to find some new videos. And the offline recommendation system is for the team to build and maintain and make the whole model, the whole system stronger. Yeah, which means that all of the user behavior, the new data, the new feature can be a kind of the data source to feed the model and make it stronger and stronger. Yeah. And so which means in the offline recommendation system, we also use the feature service to deal with the new feature, the new role feature of the user, maybe frequently like a day or a month like that. And we extracted or embedding it all of them into a extracted feature, which we can directly use it to feed the model and train our model. Yeah, that's also that here is the two things the feature service do in the recommendation system, the online and the offline. And we should make sure when we yeah, to be honest, some of the company like some of the product put the feature service in the model layer. and the model do everything of the feature extract. But here is the things the feature service can be independent because we want to make guaranteed online and offline the consistency. Yeah, because we wanna make sure that the extracted feature in the online and offline are same. So which means if you do the same things, we can directly give you a correct answer. Yeah, and also is the output with a low latency vector, and the vector has a different is different. They have a dense vector and sparse vectors, and all of them is ready to feed the model in different way. Or in the online, of course, it's in the offline recommendation system, and in the online recommendation system, the vector or the extracted feature is for the predicted true scoring. And in the in a one word, and the feature service is the core to recommendation system, which maintain a low latency architecture. Because especially in the online recommendation system, everything happens really fast in a millisecond. Yeah, so let's move on to the feature server's workflow. And yeah, and in the predict stage and feature service extract and to extract the feature, they create an extracted feature, which is a model ready vector in the real time. And and the first step is of course retrieve the data from the UDA. And second step, here is the things like make this happen in a millisecond. We use a dia. It's directly a circular graph, which is really backend things, and I will talk it specifically in the later and to be shortly. And which is a graph like the blueprint, and to tell the system how it works and how to run the system in the shortest way. And the step three is to execute the operator in the parallel. The operator is the node of the directly circular graph, which means it's a graph, right? So here's a lot of node and the edge of the node to connect each other, and we make it as a chain or a flow, which means node one, node two, node three, and we connect it together. And uh, here is a subgraph of the whole graph, and which is also a blueprint. And we use this graph to tell the recommendation system that firstly we used to do the node one, and the node one output is the input of node two, and node two output is input of node three. And here is the like a configuration for the recommendation system. And we make the thing simply so the system run fastly. So yeah, and step four is to emit the final model ready feature, the extracted feature. Also, as a like in the e-commerce situation, the user search for click the item with a camera label, and here is the things happen, and because his action like triggers some handler, and the handler send a request to the UDA to retrieve the data and to put data to the feature service, and both online and offline. The online feature service use the backend system to get the feature vector, the expected feature, and we put the feature into the source stage, to the predict stage, and predict to predict the score and put the score to the source stage, and finally we got a uh top 10 seed item to this user. Yeah, and for the offline recommendation system, also we put a UDA data to the feature service, and the feature service to output to the feature vector, and we put a feature vector to a log or a feature repo. And here is the things we stored all of the feature and use the feature to train the model. Yeah. And yeah, so why we talk about the diag and the DSL, we talk about the directly associated graph shortly, which is a blueprint of the game plan. So we break the pipeline into the order, and we got a parallel steps that so we can like to 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 deal with it independently. So which means we make the system simple in a uh, readable way for the recommendation system. And all of the things is because we have millisecond. The online recommendation system must reply the fast as a huge scale. So we need a clean and distributed system. So yeah, and what is the DSL, the domain specific language? Uh, Basically, we use a Python to write the DSL layer, the domain specific language layer, which is you, you I'm, to be honest, it's a kind of the configuration. It's a config control layer. Uh, in nowadays in the industry way, they use the DSL instead of the configuration because the configuration is really hard to read. Like basically for the recommendation system, the old school recommendation system, they have a like three different kind of the configuration. The first is a feature list to to record all of the feature, and second is the source list, which means that they record all of the data source and their way, and second is a meta, is all of the other meta info. And but if you have a very huge recommendation system nowadays, in these three kind of configuration, like it's really hard to include everything, and it's really hard to maintain, and yeah, and to add something or cancel something here. So we that's the reason why we use a domain specific language layer, which is also a configuration like a kind of a config control layer. So we can twin the feature, add the rules, and add the parameters in the Python layer. So which means we don't need to rebuild the C++ binary backend operators. And so we can directly to change some of the Python layer and keep the online or offline logic in sync. Yeah. And yeah, and from here I will talk about how to like to implement the recommendation system in a engineering way. So before that, we talk about the feature service, the UDA, or the whole workflow of the recommendation system, and from that, uh, the 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 directly associated graph and the DSO layer, which is a super engineering way to explain why how the recommendation system run in a millisecond level. Yeah, and and so we use so let's start with the directly associated graph. So a diag is a directly associated graph of a feature computation dependency, and which means just like this kind of this graph, and we have an operator is the node of it, and we have an age. Age means the data dependency, and for of course as a user, like take all of the item with a camera label, and the user, the first, here is the graph of BFS. So here is such a interesting things like every stage of the recommendation system have their own graph. Like for the UD, have a UD graph. So which means the start node is different data source and to the uh, data processing node and to the output. And here is a graph for the feature service. So the start is UDA, right? So the first node is UDA. The UDA and the next is like the time decline average, and this and go to the operator 3, the normalize, and go to operator 4, the contact, and go to the operator 2 to calculate cosine. One here is operator 2 is because you know in the searching engine, and basically we have two different vectors. So basically we use the cosine to calculate the angle of the two different vectors to to calculate the relevant score, which means the cosine is the smaller cosine, the higher relevant score. Yeah. So here is a reusable operator. So we give it number 2. Yeah, and finally to output. So, and why we use the diag? So the diag enable the parallel execution of the independence feature, and they avoid the random computation, which means we use the whole we have a whole graph. And when we use the feature surveys, which means we need to create a subgraph based on the output, like the item name, and we can reverse topologic to find the upstream node and to build a small subgraph. And we can directly use this subgraph to run the feature service, which means it's the shortest way to run it, and also the fastest way. So which provide the fastest the quickest way to run the system. That's the reason why we use a dial. And of course, we use a dial. We don't need to uh because the recommendation system we need a fast. So we use all of them. We use the C++ to write it. So and we here is another benefit that we use the dial, which means we don't need to change the C++ binary the C++ things, and we need to rebuild it again to the binary. And because it's a really huge system, and each time we build it again, we compare it to the binary, it takes like 2 or 3 hours. And the third, how it fits the pipeline, and it's run inside the feature service during the predict. So oh yeah, so for the predict, we still have a graph. So the feature service is also a node in the predict graph. So that's the relation of them. And we can use a version the diag to keep online or recommend or offline recommendation system in a sync and allow them to easily to roll by. Yeah. Because like the recommendation system creates like $1 million just per minute or per hour. And if something wrong, the company will lose a lot of money. So rollback is the quickest way to deal with the question. And about the operators, operator is like in this graph is a node of each node is operator. Basically we have a provider and adapter. Provider means the provider data, just like the UDA provider or some database provider, the A-base or MongoDB or PostgreSQL database like that. And adapter is to deal with them, like to calculate, to do the computation like that. So what is this? It's a small and reusable, just like the cosine calculation, like this operator, and reusable unit of the feature logic with a clear input and output schema. Yeah, and it compose into a DAG and running entirely where dependency are low. Yeah, and why we design it as a simple operator. In the engineering way, the smaller operator, the clear operator, the better operator. Yeah, because we can to change the operator in a small way. So which means the smaller operator we can easily to control and easily to read and easily to add some new feature in it. So make the things easy. Yeah. And yeah, let's move on to the DSL. It's another important technology in the recommendation system, also in the large scale distributed system. And what is this? Is a basically we use a Python because the Python is the most like readable language to easily to understand and to write a whole specific language layer, and which is a config or control layer to declare the feature and the rules of it. Because the feature has their own relationship. Like the feature, yeah, like some, for example, uh, like the user, they have the user behavior or the user state, like they click the items with a camera label so many times, and then after and this feature including the stay times, like he stay in the item page with a camera label like uh, a minute or 5 minutes, and also including the click times. He clicked the camera with 20 times, more than 20 times, or like that. So the feature have their own relationship. So we can easily to show the relationship of the whole the whole feature in a Python layer because the Python language has their own data structure. Yeah, so it's readable for to understand and to change or add instead of using a terrible configuration field with all of them at least from the first line to the end. Yeah, and it's also defined once and same behavior in the training and serves, which means yeah, and because the DSL layer we can directly compare it to the diag. So which is the relation between the diag graph and DSL in the system? We change the DSL as a configuration to control our goal is to use the DSL to control the system. So we change the DSL layer and we compare it to create a diag and we use the diag to we give it the diag to the system. So the system uses a diag and some output like we know what we want the output. We use the output to reverse topologic to find the whole subgraph. Yeah, and 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 we got a subgraph and system run a subgraph to run the whole system. So that's the relation. That's with how we use the DSL and to create a diag and use a diag to control the system. That's a whole flow. Yeah. So when we so once we define the DSL layer, so we defines the diag graph and which means we define so we control the recommendation system behavior. So the same, which means the same graph we can use in the online or offline. So it's also control the same behavior in the training time or a certain time because the offline recommendation system we use this for training and online is for serving to the user to real-time user. And why it's matter because it shifts really fast because just mentioned before, like we use the C++ for the backend binary, and we compare it to the binary, so it's which means it's run really fast. But uh, it it also means like we when we want to change some of the C++ operator, and which means we take a lot of time to rebuild it. And here's the things, the benefit of the BFF DSL, and which means we can set some flag in the backend, like the G flag use. And we can directly to add some features, uh, some 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 attributes, some input, output, some elements in the Python layer. And because we register the C++ operator in the system, so which means we can directly add some new things, new feature in the Python layer without changing any C++ operator. Yeah, that's really speed up the whole develop process. Yeah. Now everyone like to rebuild it again and takes 3 hours. Yeah, and it's also safe because we didn't change any C++ backend operator, so it's really safe and easy to type the schema into validation or rollback. Yeah, and it's also readable and reusable instead of using the uh, a huge configuration field. Yeah, and the output of the DSL is a diag, so that's how we use a DSL to control the recommendation system. After talking about these two super important technology of DSL and diag graph, and that's the two things like make the whole system, the feature service or the recommendation system run really fast in a millisecond. So right now we talk about a whole feature service. So uh, the output of the feature service is really easier because they have a two-way. The online for the serving, the output is a user side real-time extracted feature and per request. Like you click enough, like okay, you click 20 times for a atom, okay, that's enough. And here is a request. And all of things the system did is for this one request. And and output this one to feed the predict state directly and build for the low latency and high QPS, make the everything run really fast. And they also shared across the product and feed and one feature layer in many use cases because make everything in a same way to same methods to do it because we need to make sure that everything especially in the feature service we need to make sure that every product use the same feature service in the same way. Yeah, because in the real time product uh, like some ADs recommendation or some items product recommendation, like just like in TikTok, in Instagram, and did such that that kind of company doesn't have only one product. Like they both have the video and the e-commerce, so which means they have a different part department and same feature service component or other names component can make sure the two teams can work together with using just one feature service and make sure that the training part or the online serving part use the same baseline. Yeah, and of course for the offline, the training time and runs the same runs the same spec to build and maintain the feature database. And we'll talk later about the feature database and which also guarantee the training server priority for the reliable the A/B test for the faster operation. And in one word, then the feature service is a reusable model that extract and transform the raw features into the extracted feature, the model ready feature, where the diagraph and the DSL layer and they work together. And yeah, and how and yeah, and how does the feature service extract and store the feature vectors? And here is the thing, here's the graph. Like, we extract the raw feature. The raw feature is key value. The key is like click times and value is the vector of the value is 20, the times, right? So the all feature is that kind of thing. The user feature, the item feature, the context feature, all of them are this kind of structure. Yeah. And we use the feature service to extract it to a vector, but the vector is also a key value. The key is a unique index, is an ID, and basically we use a hash function to get ID, and the value is vector. It's a dense vector or sparse vector like that. So the key is ID, maybe is one, and the value is the vector of the offline offlayer key value, the click times 20. This is the value to invite into the vector. Yeah, and we put the vector to the feature store, and the feature repo is a really huge repo. It's a really huge data source. So uh the feature this repo record all of the features here is so many features in here. So we really that's the reason we should have an ID to search it because for the training time the algorithm engineer just know like they know they use what kind of the feature to train the model. They just know the feature name, but they didn't it doesn't means they can easily to get a vector of it. So here is the things they have a feature name and ID they can map in together, and they can directly use the ID and to as an input. So the feature repo will find the vector really quick. Yeah, and here's a design of the like the feature service is also reused for the feature service. Yeah, and so we store the feature to the feature store feature repo. Firstly, of course, for the offline training, we can just like as you are an AI engineer and you want to train the model, and you just want to put the feature and the feature name, the click times, right? So you wanna put the click times for update the click times for model training, and you just input the feature name, the click time, and the repo will find the click time's ID and use the ID to search to retrieve the vector of it. Yeah. And for the online interface, it's also a fast lookup of the latest embedding during the prediction, just as this graph, like here the front is the uh, online recommendation system we talked before, the UDA to the feature service and feature service to hash a key and also create a vector, and both of these two to store in the feature store. And also the vector is to feed the online recommendation system for the predict and sort. Yeah. And after talking about a feature service in a specific way, yeah, we talked a lot about it, like how it works in how is the high level architecture of it and how it works in an engineering way. We use a diag, the directly acyclic graph. We use a domain specific layer to control it and make it run the really small part of the whole program, and and that's we run the whole feature service in a millisecond, which is really fast. And yeah, and yeah, so after we have a very powerful feature service, the other things make really easier because in the store stage, we put the store's input is the output of predict the predict to get a score of each candidate and to give it to the sort and sort to do the rank and re-rank. Yeah, and the sort state is for the rank the candidate by model predict sort, and to applies the sorting logic plus some business rules. And to be honest, the sort stage doesn't have a lot of like the logic in here or in the business sort. This is because our nowadays model is really powerful, and we don't need to use any like class rules in this stage. Yeah, and the thing is the model, our nowadays model is generation model, and the generation model means the model might be lying, and we how to control the lying. Here's a strategy: the more model we use and the more lying the powerful the result they create, but they might be lying. Because how to control this trade-off, which we can control it in the easiest way. We didn't use it. We cut the flow. We use a very short chain, just predict and sort, just sort and output it. And we trust our model's performance and didn't add some other rules or others logic in here, which also create some other latency or times. Yeah, and yeah, and nowadays industry like the company they didn't add too much logic in here, but they focus on the model and to get to train a powerful model inside of to create a strategy in here. And the outcome of the sort is the final order feed show to the user, like when you renew your stage and the new page is in here, and you can find what you want in here. And it's a lightweight, of course, it's a lightweight score, uh, and stable, and yeah. And the output is a top 10, like top 10 or top 20 of atoms for you for the user. Okay, so today we talk about the online recommendation system, about a real-time scoring and with a low latency feature serving, and we talk about the feature service is a online is a feature extraction and transform engine, and we use the backend since the directed circuit graph and some operators to control the graph in the backend, and we use the DSL layer, which is like a configuration to control to create a graph and use a graph to control the system running. Yeah, and we talk about user data accessors, which is a really fast user data access layer and returning the normalized user side signal for the feature service. And we talk about diag, the directed circuit graph, and domain-specific language. And yeah, we also talk about the feature store, like we use a key value. The value is a vector. The key is the index, both to store the feature for the model training. Yeah, and of course for the online lookup and for the offline training paths, and we talk about the modern like predict source stage, the pipeline for it, and which is really simple architecture that help the whole system run is really fast, with a low latency and fast speed and QPS, and yeah, and here is all of the today's information. And any question? No question? Easy?
If you have any questions, you can add to the chat or raise your hand, or maybe email Hangdao after. Thank you so much for your presentation. That was lovely. As a reminder, all of our recordings, including this one, are uploaded to our Student Learning Hub webpage. The um, link to which I will share in the chat. And then our next course is on November 21st, also at noon. And that will be building a scalable multi-threaded processing system on AWS Cloud. And I'll also share that registration link in the chat too. Oh, you do have one question, which is, how does large language model help recommendation systems?
Yeah. Um, the LLM really, yeah, that's a good question. The LLM basically used for the like firstly the recommendation system is like a more like a searching engine, and we use a vector in here, and the LLM is to use in a semantic layer, because you know uh the searching engine is basically based on the vector. The vector just makes sure that everything is same, because uh the camera and the query is a camera, and we got a camera, so we just make the things is same, but we cannot make sure these two things is the same meaning. So the LLM is here to do the re-ranking part, and we use the LLM to make sure our output and uh, make sure our output is correct in the semantic layer, and which means the searching engine is for the for the vector to make sure that the word is same, and we use LLM to make sure the meaning is same. Yeah, here is how we use LLM.
Okay, great. Since we don't have any more questions, speak now or forever hold your peace. All right, yeah, we can end. Thank you again for joining, and Hangdao for your presentation, and we'll see you on the 21st. Have a good weekend, everyone.